Hello everybody, thank you for joining today. My name is Manim and today we're going to be looking at renewable and non-renewable energy sources. So we have a couple of land injectors and that's to be able to define renewable and non-renewable and renewable energy sources and to understand the need to switch away from non-renewable sources and their cons to renewable energy sources. So let's get right into it. Now, how can we actually define non-renewable and renewable sources, and what are some examples? So, a non-renewable source is an energy source which cannot be replenished in a reasonable amount of time, such as fossil fuels. So, if you remember, fossil fuels are created by the ancient remains of dinosaurs, which are buried deep underground and have been exposed to huge amounts of heat and pressure, and that's how turned their fossils into oil and gas. Well, coal and gas, which are fossil fuels, and nuclear fuels, which rely on ore being dug up from the ground, well, these are non-renewable because they take millions, if not billions, of years to replenish supplies, which isn't really reasonable at all. So they're non-renewable supplies. Then we have renewable energy sources, which is where energy sources are constantly replenished. So these are things like solar, wind, and hydro. Right, the sun won't stop shining for at least a few 100 billion years. The wind won't stop blowing either, and neither will the oceans just dry up eventually. So these are sources which are constantly been going and will continue to keep be going, and no matter how much we use, the overall supply won't really diminish at all. Now let's have a look at some pros and cons for both non-renewable sources and renewable sources. So let's start with non-renewable. Well, pro of non-renewable is that they're very, very reliable. The power stations can easily be ramped up or ramped down to match demand at a moment's notice, right? The supply of power coming from the power stations is very constant. And also, they're relatively cheap to maintain now as the infrastructure is already in place throughout the country. Now, some cons of non-renewable is that they release carbon dioxide and sulfur dioxide, which can cause acid rain. So these sort of toxic compounds dissolve into the clouds and they cause the rainwater to acidic, which starts damaging buildings, statues, all sorts of things. Also, carbon dioxide is a greenhouse gas. It contributes to global warming, but I don't really think I need to write that since that's very, very obvious. And also, the biggest con is that supply is running out. It's estimated that we'll run out of oil in the next 150 years. So what will we do after that? Now we'll have to turn to renewable sources. So a pro of renewable source is that it's an infinite supply. It's the sun won't stop shining, the wind won't stop blowing, the waves won't stop crashing. So we have an infinite supply of power coming from these natural sources. Also, there are non-toxic byproducts of any sort of process that they have to go through to actually produce that kind of energy. And also, they're becoming very efficient. Like solar panels in the past few years have become even more efficient than coal stations. So we are making great leaps in efficiency. But some cons are that they still release greenhouse gases such as water vapor. Now, a lot of people get very confused and think, oh, water isn't a very dangerous element. And you're right, it's not. But it still contributes to global warming because a water molecule can still, water vapor molecules still absorb and re-emit infrared radiation. Also, there's very expensive infrastructure associated with renewable sources such as huge wind farms, huge solar farms, huge tidal wave factories. So again, the infrastructure is very important, and also they're quite unreliable. Like at night, solar panels don't generate any power. If it's not windy enough, or if it's too windy, wind turbines have to either be shut off or just don't spin at all. And also with waves on calm seas, not much power is generated at all. So they're unreliable and they can't easily be controlled to match the level of output that's needed. So they need huge banks of batteries go along with them to sort of provide a buffer between the actual power source and the power delivery.